All right, so guys, this is question number 2 from 7.4. And it says, a medical researcher says that less than 74% of adults in a certain country think that healthy children should be required to be vaccinated. Okay, so the first thing I'm going to do, I'm going to read that sentence again. Medical researcher says that less than 74% of adults in a certain country think that healthy children should be required to be vaccinated. Okay, so they're saying that the percentage is less than 0.74, because as a decimal, 74% is 0.74. This is our claim, right? So when I look at this part right here, y'all, I'm going to choose a less than 74%, right? Okay, so let me come back over here. Let's pick A. We're going to put 74. That's the claim. That's all we're trying to do right now. Okay, so now the second part is asking us to figure out, can we find our null and our alternate hypothesis? We definitely. Okay, let's come back over here. So since we know that the claim is that the percentage is smaller than 0.74, the opposite of saying that would be that the percentage is bigger than or equal to 0.74. Okay, so remember, anytime I have the equal to part, y'all, that is our ho. And if we don't have the equal to part, that is our ha. So this is what I'm looking for. I'm looking for, when is it going to say that the ha is less than 0.74 and the ho is bigger than or equal to 0.74. So let's go through our choices right over here. So we want the ha to be less than 0.74 and the ho to be bigger than or equal to 0.74. So right here, it looks like these are going to be my choices. So 0.74 on both of them, right? Because we're saying that the ho is smaller than, bigger than or equal to, and the ha is less than, okay? So let's check our answers. And okay, we got that part done. Okay, part B, we want to find our critical regions. Okay, so look out, I'm going to take a screenshot here and we're going to see if we can critical region. So let me upload that picture here for us. Okay, here we go. So now that we have this part right here, remember y'all, we're going to figure out, is this a left tail, right tail, or two tail test? In order for us to determine that, we always have to look at the ha. Since the alternate, since the HA, that arrow is pointing to the left, this is telling me this is going to be a left-tailed test, okay? So I'm going to draw a rough picture here for you. And so here it is, looks something like this, right? And notice what our alpha was in this case, y'all. Alpha was 0.10. So remember what that means. Since this is a left-tailed test, it means that the area to the under my curve to the left is 0.10. So what we're trying to do is we're trying to find this critical value Z0 right here, okay? So the way we can do that, y'all, we can go inverse norm. And remember, whether I'm using my calculator, y'all, whether I'm using my table, they always both tell me the area to the left. So in this case, my area to the left is a 0.10. So let me get my calculator here going. Let me clear all this business. So we're going to go second in vars. We're going to go to inverse norm. We're going to go 0.10. Okay, and so I'm coming up with a negative 1.28, and I believe it asked me to go to 2 decimal places. So negative 1.28, yes, it is telling me to go to 2 decimal places, and let me just verify my calculator. There's nothing, 281, so yeah, negative 1.28. Go ahead and check our answer. So we're going to go negative 1.28. Okay, all right, so we got that part. Now, the next part of the question says, well, once we do that, what are my rejection regions? Let me come back to my picture. Okay, so now that I have my picture, y'all, this here is my fail to reject region, and this is my rejection region. So remember, here's that critical value. Anytime I'm to the left of this number, that's going to be my rejection region, okay? So anytime that Z is smaller than negative 1.28, I'm going to fall in my rejection region. So look, I'm going to come back over here and I'm going to say my rejection region is smaller than negative 1.28. Okay. So, all right, we got that part done. Okay, now let's take a look. Now we want to find our standardized test statistic. Let me show you how I'm going to do this piece, y'all. So I'm going to go back over here. Let me upload that picture. Okay, right here. And then I'm actually going to upload another picture. Let's see if I can find it. I believe it's this one right here. Yes. Okay, so this right here, y'all, is going to tell me how I'm going to find my standardized test statistic. So we're going to say, we're going to look for P hat, we're going to look for P, we're going to look for Q, and we're going to look for N. Okay, so let me come back to the original problem. Okay, so our P in this case, y'all, is the number 0.74. So we're going to find our P hat. Our P hat is the 0.71 because 71% think, oops, it's my alarm, guys. Let me see if I can find it. It's in the other room. It's okay. Not a biggie. 0.71. What is my N in this case? My N was 400. Okay. The other thing we need to know, y'all, is we need to find our Q because there's a value of Q right here as well. Okay, so the way we find Q is going to be 1 minus P. So 1 minus 0.74 should be a 0.26. Okay, so I got my values for P hat, for N, and for Q. So let me see if I can do this part here. So the formula says Z equals P hat minus P divided by PQ over N. I'm going to turn off my alarm real quick, guys, on my phone. Hold on. All right, sorry about that. Y'all, that was my, I don't know if you could hear it or not, but I could hear it in the other room. It's just my alarm on my phone. All right, let's see. So P hat, what was P hat? P hat was 0.71. Okay, so we're going to have 0.71 minus P, which was a 0.74, divided by P, which was 0.74, Q, which was 0.26, divided by our N, which was 400. I'm going to do all of this step right here, y'all, on my calculator. So let me show you how to do this. Let's clear all this, parentheses, 0.71 minus 0.74 divided by the square root of 0.74 times 0.26 all over 400. All of that is on the inside of the square root. Okay, so the number I'm coming up with is a negative 1.37. Okay, so let's see. So my critical value, negative 1.37. So let's check our answer right here. Negative 1.37. Boom, there we go. We got it. Okay, so now the question is, do we reject, fail to reject, all that kind of fun stuff. Let's see if we can figure this out. I want to come back to my slide right over here. Here we go. Remember the value we came up with right now? A negative 1.37. So I want to point something out. If this number right here, y'all, is a negative 1.28, then a negative 1.37 is going to be to the left of that. Okay? So what region did we fall in? We fell into the rejection region. Okay? So we're going to reject our null hypothesis. Okay? Now I'm going to upload another slide. I know there's a lot of slides. Let me get to it. Okay, so we fell in our rejection region. Let me upload one more slide. Let's see if I can find it. It is right here. This one. Okay. So first thing, we're going to go back real quick, y'all, because I want to show y'all something. Let's see if I can find it. It is right here. Okay, so this part is important. Our claim happened to be the alternate. So I'm going to come back to this important slide that I have right here. My claim is the alternate. And we are rejecting the null hypothesis. This is the phrase that I'm looking for. So I'm going to come back to my problem in my lab, and I'm going to say there is enough evidence to support the claim. So look, when I come back over here, we are rejecting the null hypothesis because we fell in that rejection zone, and there is enough evidence to support the claim. We're going to check our answer, and we got it. Okay, so if you all have any questions, please let me know. I'm happy to help.